Here we have a few challenge problems. We've got a rectangular garden. The length is 3 feet more than 3 times the width, and the diagonal is 4 feet more than 3 times the width. Find the length and the width of the garden. So we'll start with a rectangular looking garden. Let me call this L for the length, W for the width. And the length is equal to 3 feet more than 3 times the width. So I'll start with 3 times the width and then add 3. That'll be my 3 feet more. The other information is about the diagonal. So let's draw in the diagonal. And well, we can call it D if you like. The diagonal is 4 feet more than 3 times the width. So we'll take 3 times the width plus 4. All right, at this point, I kind of want to stop because we thought that this was a problem about a rectangle. But instead, when we're doing the diagonal, we really kind of want to focus in on the fact that we have a right triangle. Here's the length, or the width is W. The length is 3W plus 3. And then the diagonal is 3W plus 4. All right, so what I'm going to do is I'll use the Pythagorean Theorem because I have a right triangle that this length squared, so W squared plus 3W plus 3 squared is equal to the hypotenuse squared. So it'll look like this. W squared plus 3W plus 3 squared equals 3W plus 4 squared. So if I multiply all this out, so W squared plus 3W plus 3 times itself, you have to FOIL that all out, you'll get 9W squared plus 18W plus 9 equals, multiplying all this all the way out, distributing, we'll get 9W squared plus 24W plus 16. All right, now what we'll want to do is move everything over to the left and combine all like terms to set the equation equal to 0. So minus 9W squared from both sides, that kind of works out nice because that adds to 0. Minus 24W from both sides, and then minus 16 from both sides. What I get is W squared minus, that's 6W, and then minus 7 equals 0. And now you can solve this by factoring. I would choose factoring instead of the quadratic formula because I can easily think of two numbers that multiply to negative 7 and add to negative 6. That would be negative 7 and a positive 1. So this factors like x minus 7 times, not x, I'm using w instead of x. So w minus 7 times w plus 1 equals 0. And now you can solve that quadratic equation by saying w minus 7 equals 0 or w plus 1 equals 0. So the two answers we get are w equals 7 or w equals negative 1. So again, remembering that this is a width, a negative width doesn't make sense. So I'll stick with w equals 7. So here I know that the width is equal to 7, and I think I was using feet, 7 feet. And the directions was to find the length and width of the garden. So we go back to this piece of information here. The length is 3 times the width, which is 7, plus 3. So 21 plus 3 is 24. So the length is 24 feet. So again, this was a little bit of a tricky problem because it started with a rectangle, but then really you want to think of the two legs in the diagonal as a triangle and use the Pythagorean theorem. Remember to put everything in parentheses, and if you have to, write out the whole thing so you don't forget 3w plus 3 times 3w plus 3, you're going to have to multiply everything together, okay? Lots of times we forget those cross terms. Right.